Okay, seems like I was muted, so I'll start again. Good afternoon, everyone. I hope that you're having a good day so far. Today we are going to talk about different sensor technologies, and we will start by reviewing some of the old-fashioned ones, the ones that you all know. We'll go over those and maybe give you some little bits of information that you didn't know about them and their applications. And also we will talk about new technology that we have been working on, and we haven't and it's the product of the future. So I will start by the most commonly known and most commonly used technology that is used for occupancy detection, passive infrared. So passive infrared technology uses the movement of a heat source for detection. How that works is you have a pyroelectric element that would create a signal output in case of a movement of heat signature between different segments of it. And then we usually use some sort of a lens to divide that surface into even smaller, finer segments to give us more detection zones. So how that system works is, as you can see in the picture on the left-hand side, if a person or any heat source moves from one detection zone to the next detection zone, we will have an output signal on the output of our sensor, and that would be translated into some sort of action, whether it is to turn on the lighting, turn on the HVAC, or some other action that is of interest to us. The accuracy of this technology depends really on how well or how many segments we create on the pyroelectric element, and using the lens and the quality of the pyroelectric element. Some of the main characteristics of this technology are that we need line of sight for this technology to work. So that heat source must be directly in front of the lens and the pyroelectric element for it to be seen. And if you have something that blocks the heat signature in some way, whether it's glass to mask off the heat signature, or there is a partition or something even denser, then you won't have any detection. This requirement actually creates a useful characteristic for us, which is the potential to crop and limit coverage pattern and isolate detection zones. So the most basic way of doing this, as you may very well know and have used, is just put a tape and cover some portion of the lens. Not what we have in mind, but that's basically just blocking the line of sight of the sensor and reducing the coverage and cropping it to our desired desired area. In Steinel products, we use a mechanical method to do this cropping, which is way more accurate than just putting a tape on the lens and go with trial and error and hopefully get approximately the coverage we want. The other characteristic is requirement of heat signature in motion for detection of presence. So if you sit quite still, or let's say you're taking a nap, there's a good chance that the sensor won't see you because you're now just a stationary heat source. So this is one of the problems with that most people have with passive infrared technology, that you need some motion. You can't just be sitting still and expect to be detected. However, that definitely depends on the sensor and the resolution of the sensor that you're using. If you're using a high-dense, high-definition sensor, like our IR Quattro HD, you can have minimal movement and still be picked up in a very good coverage area. Some of the applications that passive infrared sensors can be used or are in high bay applications in warehouses, gymnasiums, these kind of places, because when you have these high ceilings, other technologies don't exactly work very well. You end up, and a lot of times you actually have big movements around. So it's not a, someone sitting in a corner working in a warehouse. Most of the time it's forklifts and people walking about in the warehouse, which would satisfy the movement requirement. K-12 classrooms, because they have all these artworks, hanging decorations, and these things in the class, that will not work. That would cause problem with other technologies. When the HVAC system kicks in and all these artworks start moving, then other technologies other than PIR would be picking them up and detecting them as occupancy, whereas PIR will just ignore them because there is no heat source movement. Small offices where you hardly have any obstructions, storage facilities, especially because you have this thin walls and you have these big doors that move and create air pressure difference. That will not work with other technologies. Data centers, again, you have this big fans on your servers and on your data racks that cause a lot of hot airflow that would be a problem with other technologies. And common spaces where you have high ceilings, building receptions, those kind of areas. Those are perfect applications for PIR sensors.
Poria, we have an emailed question. This one is about the use of PIR. His comment is that his understanding is that PIRs aren't accurate enough for today's needs regarding those detection zones. Do you have any comments on that?
Well, that's a good question. For many years, PIR sensors have been dismissed as not being accurate enough and having a problem of false off, that you are in the room and the lights go off on you and you have to get up, wave, and do a little dance for the lights to turn back on. That really depends on the construction of your sensor. So if you have, let's say, our IR Quattro HD sensor with 4800 switching zones, you would more than satisfy the small movement requirement of NEMA even very easily. And the definition of that small movement as per NEMA is a human arm moving 90 degrees, which is quite a big movement. If you think about it, it's not really minor. Your arm is moving completely from one direction to another direction. And our sensor with a high definition lens and high definition pyro elements, and not one, but 4 pyro elements, will give you 4800 switching zones. So PIR is a good PIR, high definition, high quality PIR, with a lot of switching zones is the perfect solution for many applications that you have to dismiss if you have a low quality, low resolution PIR sensor. Now we move on to the next technology, which is ultrasonic technology. Ultrasonic technology works quite differently from PIR. It's an active technology, which means you have a transducer, well, at least one transducer that emits an ultrasonic signal at 25, 32, or 40 kilohertz above the human hearing range. This air wave, this sound waves, basically fill the room, fill the area of the room, and then any movement in the room will cause a Doppler shift in these air waves, in these sound waves. And then you have another transducer that is listening to the sound waves, and once it receives the air wave, the sound wave back, and detects that there is a change in the frequency, then it will consider that as a movement. This makes ultrasonic a very accurate technology, very sensitive technology, but it will have its own drawbacks because of this. So some of the characteristics of ultrasonic technology are that the ultrasonic waves fill the entire room, any space that they are in, or at least they try to. You can imagine it as a speaker sitting in a corner of the room, and as long as the room is not too big, you can go anywhere in the room and you will hear the speaker, the sound coming out of the speaker. The other characteristic is that, well, ultrasonic technology doesn't need line of sight, because these sound waves basically bounce off of the walls and everything in the room, and they keep going back and forth. So it opens the door for us to use this technology in places that there is some obstruction, line of sight is not really possible. And then the other characteristic is that, well, it's a very, as I said, it's a very sensitive technology. So slightest movement, door handle moving, doorknob turning, any decoration, any artwork hanging from the ceiling, even the airflow from HVAC units can trigger an ultrasonic sensor. Even smallest vibrations can set off an ultrasonic sensor. I remember we had a project in my previous company that we were using ultrasonic sensors, and there was one corner that would never go off. The lights would never go off. After a bit of investigation, we found out that that wall, behind that particular wall, there's a pump room. So every time these pumps turned on, that wall would start vibrating, and our ultrasonic sensor would just keep the lights on. Some of the applications for ultrasonic technology are bathrooms with stalls. So this is an easy one. All of us have seen it, that bathrooms with stalls, you don't have line of sight. So and you have all these tiled ceilings and tiled walls and tiled floor, which gives you perfect echo, and a simple ultrasonic sensor will pick up everyone who is in those stalls and make sure that the lights don't go off on them. Offices with partitions, filing cabinets, other obstructions, ultrasonic would be a great fit. Gym locker rooms, and then stairwells. Stairwells, the nice thing about using ultrasonic technology in stairwells is that the lights would turn on before you even set foot in the staircase. Because when you have a PIR sensor, you have to actually take a step in. You have to open the door, take a step in, at least one step into the staircase, and then the lights turn on. Whereas when you have an ultrasonic sensor in the staircase, as soon as you start pushing the door, lights have turned on, the sensor picks up that big rush of air and the movement of door or door handle and will turn on the light. So you're not setting foot in a dark staircase, taking 2-3 steps before the lights turn on. And that is if the sensor is located properly and has enough resolution in case of a PIR in a staircase. In case of corridors, one thing I missed about PIR technology is that you get the best detection from a PIR sensor when you're moving tangential or perpendicular to the sensor. So imagine a circle of coverage around the sensor, and then if you start moving along the perimeter of this this disc with the sensor at the center, then that would be your best detection. That would give you the biggest coverage pattern. Whereas when you have ultrasonic technology, the best coverage pattern is when you're moving directly towards the sensor, basically a radial movement, because you're compressing the air in front of you towards the sensor, so you're easily picked up. So for hallways, the best solution is an ultrasonic sensor, because it gives you great coverage. And again, same as a staircase, before you even enter the hallway, the lights have already turned on, because as soon as you turn the door handle or you start opening the door, the sensor is picking up a change of pressure in the air, and it will trigger the lights. The next technology is not really a technology by itself. It's a combination of a dual tech. It's a combination of PIR and ultrasonic sensor in one. What happens here is you have both technologies. Most of the sensors with both technologies use both methods of detection to turn the lights on or trigger an action, and then to maintain occupancy or to detect and maintain occupancy will use either of them. So if there is a physical heat signature movement, the PIR part will keep the lights on. Or if you have a cubicle, in case of the image that you're seeing in the presentation, well, the main detection after everyone has sat down in their seats, the main detection would be through the ultrasonic part. So the two advantages of using a dual tech is that you're less likely to have a false on, which you would get from an ultrasonic sensor, because you have to see a heat signature moving with your PIR section before the lights turn on. And also you're less likely to have a false off, because ultrasonic is a very sensitive technology, and it will pick up your fingers moving on your keyboard and just moving your mouse here and there, and it will make sure that the lights don't turn off on you. Some of the applications for this are private offices, where you're sitting like behind with your back to the sensor, two big monitors in front of you, those kind of situations that you're not giving the sensor proper line of sight of your movement. Conference room, where people tend to sit quite still for long periods of time. You want to make sure that the lighting situation doesn't change. Higher education classrooms, because you don't have all those artworks and these things that the kids have in their classes. And teacher lounges, common spaces where you have low ceiling and minimal movement.
We actually did have a question about dual tech as it relates actually to ultrasonic.
Okay.
This person uses dual tech for cubicles, but that's not listed on the applications. That's their standard, but you're suggesting ultrasonic. Why?
Because cubicles, 95% of the time, you're really using the ultrasonic part of the technology when you're in a cubicle. Because the only time that the PIR is seeing you, probably unless you're sitting directly under the sensor, is when you are walking to your cubicle. So you walk to your cubicle, you sit down, and then you're lost to the PIR part. So why pay an extra amount of money to have a dual tech sensor when you have a when you're only using it 5% of the time? The other disadvantage or wrong application case for dual tech is when you have high ceilings. There, you definitely can't use a dual tech sensor or an ultrasonic sensor for partitioned areas. You have to put more PIR sensors to compensate for the obstructions in the space, whatever blocks line of sight. In this slide, we have a kind of application case shown on a school system. So what kind of sensor would be, well, more or less, would be best fitted for which kind of area? So I'm going to start at top right. That US Quattro ceiling mount ultrasonic sensor looks like that's the locker room or a multi-stall bathroom, restroom. So like I said, that's the perfect application for an ultrasonic sensor. Then we have a little bit to the left, we have the IR wall switch for small janitor's closet, small storage rooms. You know, you want to just make sure that as long as you're moving stuff around or taking something out of that small room, you're in line of detection. There is no complicated situations there. High bay sensors for gymnasium area where you have all the you have the high ceiling. You definitely can't be using ultrasonic. Movements are quite big, so even a simple PIR sensor will get the job done. For the office area on the bottom right, you can see that we are recommending ceiling mount dual tech sensors, and for the individual offices, dual tech wall switches with dimming function. Single stall bath restrooms, we recommend an ultrasonic wall sensor. Hallways, we recommend the hallway sensors, ultrasonic hallway sensors. As you can see, you can have these in one-sided or double-sided. So whether you have a smaller hallway or you just want to put one sensor at the beginning of the hallway, and then if you have a longer hallway, you put several in the middle and make sure that they cover both sides of the sensor. In the cafeteria area, you have the IR Quattro HD, that big open space, a lot of tables and chairs and stuff. And in the classrooms, we have the PIR corner mount sensor. Now, the advantage of a corner mount sensor over a ceiling sensor that you put in the middle of the area is that a corner mount sensor can be easily adjusted so it doesn't look outside the door. So you won't have a case that people are walking by outside the door and then all the lights turn on. So yeah, this is brief application guide of different technologies and different types of sensors in a school environment. Same rules pretty much apply to everywhere else.
Poria, we got a question at the morning webinar about using dual tech across the entire building as opposed to using specific technology for each room. So maybe it's worth addressing that in this afternoon session as well.
Well, there are two reasons a lot of people do that. One reason is that a lot of people think that the best solution, like dual tech sensors, are a one-size-fits-all kind of thing, and which is not really. When you have a good PIR sensor that can give you even better coverage than a dual tech sensor, why not use that? And also there are some cases that you really can't use a dual tech sensor. Dual tech or ultrasonic sensors won't work if you have a ceiling height of more than 12 feet. Or if you have stuff hanging from the ceiling, you have some artwork hanging from the ceiling, pendant fixtures, all things that can vibrate. You're limited to not putting the sensor too close to the HVAC grill. Too many situations that you can't really use a dual tech sensor. And the other reason is, well, having one type of sensor everywhere in the project makes it easy, because you don't have to think, where does this sensor go and where does this other sensor go? You just put dual tech sensors everywhere without thinking, well, what is a better solution instead? The next technology that we are going to talk about is quite a radical one. I really like it. It's becoming more and more common in other industries, but mainly in security. But we have worked on it, and we have made a device that gives us the possibility to actually use this new technology to do human detection. So what this new technology, this new technology uses optical sensors to detect and count people in up to 5 separate zones. So this is great, because we have reached a point that it's not enough really to just say, oh, well, I just want to turn the lights on and off if someone's in the room or there's no one in the room. That whole binary, occupancy vacancy situation is not enough anymore. Everyone is opting for more energy saving. Everyone is trying to connect their lighting control system to the HVAC system and optimize their HVAC system based on occupancy or level of occupancy, rate of occupancy. There are some more applications that we can talk about that are quite interesting when you think about the information this optical sensor or human detector can give you. How this technology works is, you have optical sensors, they detect, and they basically look at an image of the room, compare that image with 7 million stored images in real time, and detect whether you have a human in the room or multiple humans in the room or no one. This is really, it's kind of a facial or human detection taken to put into a very interesting application. Plus, you're getting some additional information that you won't get from your usual occupancy sensor, whether it's a PIR dual tech or ultrasonic technology, which is you will get the light level, temperature, and humidity. Now you have all this information, and you can imagine what you can do with all this. What are your, as you would say, the sky is the limit of what the things you can do with all this information. You know how many people are in this area. You can even group them into zones and make to know how many people are in each zone. When do they come and go? What is the rate of people moving through these areas? You know the light level, changes of light level, you have the temperature level, you have the humidity level. That's a lot of information to have. And we're going to look at, so these are the things that this device tells you about occupancy. What is there? Was that a dog just running by, or was it an actual human in the room? Because, well, a dog also has a heat signature. So it would trigger a PIR sensor. It's a big movement. You know, your pet running around the house can trigger all of the ultrasonic sensors, all of the PIR sensors. But that would be not desirable. You really want to know, what is there? Is it a human or is it not a human? Now, how many are there? How many humans are there? That's a very important question when you are gathering all this information and tying it into other systems. Where are they located in this room? Are they close to the window? Are they further away from the window? Again, are they all standing in one line? Are they spread out? When did they come in? How long they stayed? When did they leave? The rate of people moving in and out of the area. This new sensor, HPD2, will give you all of this information. Of course, it has an IP port. You won't get all this information over a, signal line. So you can use this device to control HVAC and lighting. You can use it to schedule elevators. You can optimize the layout of lighting and control of the layout of the office. And you can increase productivity. Like I said, there is no limit on how you want to use all this information. Let's look at an example. Let's say you have a conference room. For example, in this case, our sensor is counting 7 people in the room. So you know how many people are in the room. Well, depending on the size of this conference room, you may want to adjust your HVAC system to make sure that the air is not too humid, that the air is not stuffy in the room. It's not too cold, too hot. So you need more than just, well, is there someone in the conference room or there is no one in the conference room? Now, all this information will help you make, maximize your energy efficiency and also create a better experience for people who are in that conference room. You know, they don't feel like, oh, if there are more than 5 people in this conference room, everyone's sweating, and feeling uncomfortable. They can focus on the topic of the conference or the meeting. The other situation can be a classroom. As you can see, you have a zone with no one in it. You have 2 zones with 1 person in each one. And you have a zone with 2 people in that. So overall, 4 people. You can divide the area that you're covering into 5 detection zones. So let's say you have more students only in the area near the window. Well, maybe you really don't need to turn the lights up that much, because you probably have light from outside coming in and you can turn off the other side or dim down the other side. And, all sorts of scenarios. Again, tie it back to HVAC and, control the HVAC system to fit the requirements of a classroom with 4 students in it rather than a classroom with 10 students in it. Then we have the elevator management. So you kind of create these zones that show the lines of people waiting for the elevators to come, and then you can adjust the scheduling of the elevators and how they respond to calls based on the number of people standing in those lines. And you know, if or it can tell you, well, maybe you need more elevators, or you need like faster elevators. Somehow optimize the elevator system. And another example would be cashier lines. So let's say you're in a big, you know, supermarket or the hypermarkets doing your shopping. You have big lines formed, and then half of the cashiers are closed. So if you have a sensor like this, it will tell you, oh, well, the lines are getting too big. Let's open some more registers and get people moving, and not make people stand in line for half an hour to get their pay their bill. So these are some of the applications of our HPD2 sensors as well. Like I said, this is a new technology. So many applications you can think of, and really, if you had any questions, you can give me a call or send me an email about any of the sensor technologies, applications, any technical questions you have, and also our tech support phone number and email address is there.
Porya, we did
have any more questions?
Okay. Before I open up the phones, we have a question from the chat window. What are the advantages and disadvantages of using ultrasonic versus microphonic sensor technologies?
Microphonics tend to have some problems with, as they make jokes of them, that you can clap on and clap off. Because they are working, it's kind of a microphone listening in. So it's not, it can be triggered by even human range, like the voices and sounds in the human frequency. Whereas ultrasonic is more accurate. You have less cases of an ultrasonic being triggered by a human or some, what do you call it, the normal things that make sound in the audible range, human audible range, to trigger an ultrasonic sensor.
Okay, so with that, then all the phone lines are open if anyone had any questions that they wanted to jump in and ask right now. Give it another couple seconds if anyone had anything to jump in with. And if not, you'll be getting an email shortly with a survey. So it'd be greatly appreciated if you would fill that out. And then we have our next one coming up on Title 24 in December. So thank you so much for calling in.
Thank you. Have a good day.